We are going live.
We do.
Hi, everyone, and welcome back from the break. I hope you enjoyed it. And please join me in welcoming Rick for Principal Quality Consultant at Sogeti. He has so many experience in the field. Is presenter, a trainer, an author, a consultant, and a coach. He supports many organizations and people in improving their quality engineering practice. He created a workshop on machine intelligence and DevOps testing, and he has been around and sharing his knowledge and experience in so many different positions. And it's wonderful and exciting to have you here with us and share your knowledge. So welcome, Rick.
Yeah, thank you, Karen.
And today you're going to talk about quality engineering for DevOps, right?
Yeah, that's true.
So keep in mind that if you have any question, feel free to write it on the chat. If you want some clarification, write it down, and Rick will answer all your questions when you finish talking or during the session if it's needs any clarification. So enjoy the session, and that's it. See you soon.
Okay, thanks, Karen. Well, I'll share my screen because that would be handy. And there it is. So, welcome everybody, and let's dive into quality engineering. Well, Karen already introduced me, so I won't add much to that. As you can see, I'm in a long time. This is what computers look like when I started. I'm involved in both consulting for companies, but also research and development and training courses. And the research and development has resulted in quite a number of books. So number you see here, 4 years ago, together with some colleagues, I published a book on AI called Testing in the Digital Age. And then I started getting involved in DevOps. And 2 years ago, we published the book Quality for DevOps Teams. And that's also the basis for my presentation today. And first, let's have a look what is different in IT compared to, well, many years ago, like when I started in IT. And one of the big things that strikes me all of the time is that business people, they don't ask for IT systems, they ask for business value. So having computers is a no-brainer. They want business value and they don't want to wait. So they need quality at speed. And to meet these demands, teams should work together. So, because quality engineering is everybody's responsibility. And QA and testing should be integrated in the whole process and in the people, because you don't have time to add quality at the end. So built-in quality is a key thing. And to make that happen, the teams today focus on being organized as high-performing cross-functional teams. Teams that both do stuff and run it and keep it running. And to get that speed, for the quality at speed, you need to automate everything. Although I always emphasize automation is a means, not a goal. So automation is there to support you, but not the goal in itself is not to automate. So my colleagues and I were thinking about how to deal with all these new and changing demands and challenges. And we put a lot of our knowledge in the book. And 3 of you can actually win this book at the end of this session. The book is available both in paper form and in electronic form. And I will send the electronic form to the winners. So when we thought about quality engineering, we started with what is business delivery all about? And business delivery is about delivering value to the end user. So the first thing is you need to define the value that the end user expects. And then when the value is known, you come in the scope of IT delivery. And then the first step is to detail the value into objectives that need to be met by IT delivery. And with these objectives, we want to have built-in quality, and you do that by applying quality measures. So different activities that support delivering the right value. And then, of course, you want to know if you are reaching your goal. And that is done by measuring indicators. And measuring indicators is mainly testing, because that supplies information based on these indicators that helps the stakeholders, like a product owner or other people, to support their confidence that they will have the pursued value that they're striving for. And when they have enough confidence, they decide to go live. And then we get in the scope of IT use, and the end users will experience the real value. And when they experience the real value, we will have new ideas for new value, and we get this value improvement loop, because every time you think of extra value, new value, and then if you're working DevOps in a Kanban style, you go through this loop multiple times per day, and every time add a little bit of value. However, this same voice model also applies to, for example, Scrum, where you have a 2-week sprint, and then the value improvement loop will be every 2 weeks, or even to traditional IT, where your value improvement loop may be a month or even longer. So depending on your situation, you will have more or less value added, but the basic concept is always the same. So one extra bit about measuring these indicators. Now, what kind of indicators then would you need? Well, we have made 4 groups, and actually it started with 3 groups of indicators. It is about product, process, and people. And the product related indicators are related to the business value, obviously. So in one way or another, you measure whether the business value is actually getting what people expected. And that can be measured in the real life environment, or it can be measured with things before that. And on this slide, you will see some examples of indicators. Keep in mind, there are many, many more indicators possible. In our book, we describe, I think it's 1.5 page with examples, and still that is definitely not a complete list. So the second area to focus on is process-related indicators. And that is about the IT delivery process. So have we delivered what we promised? How much is the system available? And many more things about the IT delivery process. And last, but certainly not least, about the people, the team. For example, do we have the right necessary skills in the team? And are the people in the team satisfied and happy? Because happy people perform better. So that also should be an area of focus. And then we have the 4th group, which may be seen as a little bit an odd group. It's about quality in general and about problems. And one of the reasons I always like to emphasize this group is because I keep seeing people, especially, for example, project managers, who say we can go live when there are less than, let's say, 2 highly important problems. And then I think, how can you say that there is a defined number of problems with which you can go live? Because actually it depends on the problem. So I never like measuring the number of problems. What I do advise is, for example, to look at the number of anomalies uh, compared to what you expected. Because if you're doing Scrum and you have 2-week sprints, then you know that in every sprint you will have, for example, 20 anomalies. If this time you only have 2, what's wrong? Because you would have expected more. On the other hand, if this time you have 200 and normally you have 20, you definitely know something is wrong. So that's the thing. Another thing is mean time to fix. Because if you're able to fix operational failures very quickly, then you don't need to bother so much about your quality level. Because if the quality is not good enough, you can fix it quickly anyway. On the other hand, experience shows that most people that need fixing often have so low quality that the mean time to fix is quite long. So in general, you should strive for the right level of quality. And keep in mind, don't measure many different indicators. It's better to have somewhere between 5 and 10 indicators and follow up properly on these indicators than to have dozens that you can't keep track of anyway. And also review your list of indicators at least every 3 months and see if you need to add new indicators or remove other indicators. Now, I was already briefly mentioning different kinds of IT delivery models. And what we did is we separated the models in 3 main groups. So there are sequential IT delivery models, which are mainly traditional and not followed as much today as they were decades ago. Then we have high performance IT delivery, of which DevOps is the current, you might say, a hype in our industry. But DevOps together with Scrum is what we would call the high performance IT delivery. And of course, there are some other examples of high performance IT delivery, but for as far as I can see, Scrum and DevOps are predominant. And then we see more and more organizations that have hybrid IT delivery. And hybrid IT delivery also is founded on the agile mindset, but it handles the challenges that you have when you have a large organization with many different teams and also many levels of responsibility. So that is one of the bigger challenges, and an example there is SAFe, the Scaled Agile Framework, which is very useful to deal with agile at scale problems. Now, the title of my presentation is Quality Engineering for DevOps Teams. So you may wonder, what actually is quality engineering? Let me show you our definition. So quality engineering is about team members and their stakeholders taking joint responsibility. So they take responsibility together for continuously delivering IT systems with the right quality at the right moment. So it is not about delivering the highest possible quality, but it is the suitable quality in your situation. And sometimes mediocre quality at the right moment is better than the highest possible quality way too late. And quality engineering is a principle of software engineering concerned with applying quality measures to assure the quality of IT systems. So I will get back to quality measures and what are possible quality measures today. Now, one of the possible quality measures is testing. And then you may wonder, what is testing? Well, there are many different definitions of testing, and we have updated our definition, and our definition of testing is this. So bear with me. Testing consists of verification, validation, and exploration activities that provide information about the quality and the related risks to establish the level of confidence at the stakeholders, that a test object will be able to deliver the pursued business value. Now, why do we emphasize verification, validation, and exploration? Well, that is because these are three different things working together and being very important. So verification is about checking whether the things that were written down are complied with. So if you have requirements, you want to see whether the IT system actually fulfills the requirements. Now, the problem is not always are your requirements complete, or they may not be totally clear, they may be vague, whatever. So you also need validation. And validation is about checking whether what has been delivered is fit for purpose. Now, talking about verification and validation is quite common, and you may have heard that before in relation to testing. But what we added is exploration. And why is that? Well, because take, for example, security. If you do verification for security, you make sure that the system complies with all the requirements for security. And if you do validation, you see whether it's fit for purpose and actually is a secure system. But you also want to explore whether you can't get in without the proper authorization, for example. So you want to explore other possibilities. So that's why today we talk about verification, validation, and exploration. So testing is part of quality engineering, but quality engineering is much more than just testing. And in a couple of slides, we'll see that we distinguish preventive and detective quality measures. And a quality engineering is mainly about preventive quality measures. And by applying them, you limit the number of testing needed, and especially you limit the number of retesting and regression testing needed. Because if you have high quality from the start, or at least the right quality from the start, then you only need testing to confirm that the quality is as expected. Now, in quality engineering, there are many, many different activities. And we grouped these activities in 20 so-called topics. And you see the overview of the topics here. And unfortunately, in this presentation, I don't have time to go in detail of all of the topics. But I would at least like to tell you that we have two groups of topics. We have the organizing topics, which are about orchestration, planning, etc. And they focus on multiple teams. And remember, in Agile at scale, we often have multiple teams working on the same thing. Well, that's where you want to organize across teams. Also, there are a lot of activities that are performed by one team within the team, and that is where we have operational tasks with a focus on the single team. Now, please be aware that this is not a black and white division, because some topics may be partially organizing, partially performing. The first topic is called quality and test policy. And let me briefly go into quality and test policy. Now, it is about, or one of the possibilities of your policy, and that is often chosen, is about risk-based development and testing. It is about, if you have a higher risk, you want to apply high quality measure intensity, so high intensity quality measures. And if it's a medium risk, you have medium intensity, low risk, low intensity. If you have no risk at all, you don't take any quality measures, but also you don't develop. Because no quality risk means if this goes wrong, nobody has a problem, so nobody needs it. And therefore, I always say no risk, no development, and no testing. That saves a lot of time. And also, if there's no risk, but you still develop it, you have the risk that something else fails. So keep that in mind. And using the risk and the risk class, you can classify what quality measures you need to do. And we generally use bullets to indicate how much quality measures we need. The more bullets, the higher the intensity of the quality measures. And all of this is done to find the balance between the cost of failure, because if you have low quality and things fail all the time, you have to fix it and maybe even pay the damage for people. On the other hand, if you make sure that nothing will ever go wrong, probably the prevention and detection costs are so high that it is simply not achievable. So you need to find the right balance of total cost of quality. And that's also what your quality and test policy are about. Now, after you have a quality and test policy, you also should have a quality engineering strategy. And you may wonder, what is a quality engineering strategy and why would I need it? Well, one reason to need it is that everybody involved should know what to do and when to do it. So the when thing is often solved, for example, in Scrum, and you have a Scrum board, but you also need to define, what do we need to do? How do we develop? How do we make sure that we build in quality? And how do we demonstrate that the right quality is indeed built? For that, you need continuous feedback, preferably automated in a CI/CD pipeline, for example. And part of the continuous feedback is delivered by continuous testing. And all of this supports the so-called shift left move. And shift left means doing the quality measures as early as possible. So build in quality from the start instead of just building something and in the end determining that it's not good enough and you need to fix it. And that will cost a lot of extra time. So let's then have a look at quality measures. What is a quality measure? And for the non-native English speakers amongst you, I would like to warn you, because the word measure in English actually means two things. One meaning of the word measure is to measure something, and that is getting numbers so that you know how big something is, for example. Here, however, we mean something else. With a quality measure, we mean a group of activities, so things you can do to achieve a certain level of quality. So a quality measure is taken to make sure you have the right level of quality. And there are three groups of quality measures. And the first group is about building the right quality in your system. They are also known as preventive quality measures because they prevent a lack of quality and they support achieving the right level of built-in quality. And examples of preventive quality measures are pair programming, where two people work together to build in the right level of quality, but also a definition of done, which clearly states what the level of quality is that you need to meet to be able to say this is done and we'll go on with the next task. But also things like proactive patching, because in DevOps we have both development and operations tasks. And like you can see here, we have, for example, pair programming as a quality measure that is preventive in the sense of building in the right quality. And you may have proactive patching, which is more from an operations point of view, where you say, okay, this could go wrong in the future. Let's fix it now. Build the quality in when we still can. The second group is detective quality measures. They are about demonstrating the quality level. So aimed at measuring the level of quality, and actually testing is no more than measuring the level of quality to supply the information to the stakeholders, and they know whether it's good enough or if it's not good enough, how to improve. And examples are reviewing, where, for example, you look at requirements or code or whatever to see if it's the right quality, and test design and test execution to actually prepare the right tests in measuring the quality level. And another one is code analysis, which can be done with tooling. You may be aware of SonarQube, for example, where we get statistics about the code quality. And last but not least, we have corrective quality measures to improve the quality if something has happened and the quality was not good enough. So they are about improving, for example, by solving technical debt and to fix any problems with the quality level of the product. An example is feature toggles that, for example, operations people use to turn parts off if something goes wrong, but also you can use it from a testing perspective. If you do A/B testing, you can have a feature toggle that toggles between multiple audiences. Other things are reactive patching, refactoring, rebuilding. So they're all about improving the quality when you still can. And then you may wonder, 3 groups of quality measures, but how do we know whether we need to apply these? And we have specific quality measures that are applied for a specific IT delivery item, and it depends on your test intensity or your quality measure intensity, actually, and the relevant quality attributes or quality characteristics. Examples here are for Amigo sessions, where you have a review session where the people in the review have specific focused areas of attention. So you have different people with different backgrounds and they look at something specific. For example, operations people will have other focus in their review than a developer. Other examples are performance testing, usability testing, security testing, all these kinds of quality measures related to specific quality attributes. And, well, I already mentioned feature toggles. Apart from the specific quality measures, we also see some generic quality measures that apply to all of the IT delivery items. For example, a definition of ready, which specifies if a requirements document is good enough to put it on your sprint backlog, and a definition of done that defines whether a user story or a feature or any other IT delivery item is good enough to go to the end of the sprint. But another generic quality measure is coding standards, because if you have coding standards and people comply with them, then you prevent having problems in your quality, because coding standards generally are a measure to build in the right level of quality. So, quality engineering strategy is about built-in quality. A quality engineering strategy relates to quality measures with the IT delivery items like user stories, features, etc., and indicates the intensity of the quality measures that are needed. So it is about quality measures and the intensity level. And then how do you actually assign these quality measures and look at the intensity? For that, we made an Excel template. And at first glance, it may look quite complex, but actually I can promise you that if you use it in real life, it makes life so much easier. And well, let's just have a look. So, and if you can't read this table here, no worries, because in the next couple of slides, the table will be presented much larger. But first, it is about what should be in such a table. At the left side of the table, we have IT delivery items. So the user stories, features, epics, or whatever. So you make some rows there with the IT delivery items. And for every IT delivery item, you think of the relevant quality attributes like performance, security, usability, whatever. And maintainability also is an important one, by the way. And you do a risk assessment. Now, unfortunately, I don't have time to go into details of the risk assessment, but it results in 3 possible risk classes, A being high risk, B is medium risk, and C is low risk. And remember, there is no D for no risk, because if there's no risk, we simply won't build it. Based on the risk class, we then determine the intensity of the quality measures that we need, and we select the appropriate quality measure. So let's have a look in a little more detail. Here you see an example, and this is one table, but to make it large enough, the parts behind each other instead of, on top of each other instead of behind each other. So we have a user story here. We have functionality with a risk class A and performance with a risk class C. And then we have different intensities. And like I said, more bullets indicate a higher intensity quality measure. So for functionality, we have risk class A. We have 3 bullets for the preventive quality measures to build quality in. And an example is pair programming. Then we have 2 bullets for static quality measures. So we judge that 2 bullets is enough there. You don't need to have 3 bullets everywhere. And then for the third column, we have 3 bullets. And for the fourth column, for the corrective quality, we also have 3 bullets. And then first you assign the bullets, and then you assign the quality measures. So all in all, that looks like this. And yeah, you can download the template if you like from our website. The website is tmap.net. There's downloads, templates, and then it would look something like this. And let me look up the template. So this is the basic template. You put in your IT delivery items. You can put in your quality characteristics and your risk class. And then you put in the bullets for the test intensity. And when you have assigned the bullets, then you find quality measures that align with your bullets. And if you want some inspiration about quality measures, we have a long list here with preventive quality measures. We have some generic quality measures and some specific quality measures. But we also have the static quality measures like inspections, reviews, audits, code analysis by tooling, the N Amigos session like 4 Amigos, and many more. We have dynamic quality measures, which are, for example, about testing. So automated model-based testing, but also observability, performance testing, whatever. And finally, also some examples for corrective quality measures. So based on the list of the quality measures and the intensity you put in your template, you get something like the example I just showed, where you see what kind of quality measure applied. And well, that's basically the idea of the template. Then, of course, you wonder, how do I know what quality measure to apply? And let me give an example based on testing, because my background is very much in testing. And that is this. This is the generic process of testing. There is some sort of a goal that you have, and that's, of course, the same goal that you have with development. So it's about the pursued business value. So what business value do we want to have? Then there should be some requirements, specifications, whatever. And quality risks. So like I told before, we do a quality risk assessment. And based on that, we determine how to apply the quality measures for testing. And that may be unit testing, system testing, acceptance testing, because the basic process of testing is always the same, but the actual test cases and test scenarios that you develop are obviously different for unit testing and acceptance testing. With test design, you have multiple test design techniques, and basically test design techniques give you test situations, and from these test situations, you create test cases. You also find your test data, and based on that, you create test scenarios, and the test scenarios are about what do I need to test, and if you execute manually, that is all you need. But if you use automated testing, then you also will need to create test scripts, which are the automation code to guide and run your tool. So all of that is part of test design. And then you have test execution, where tests are actually run and the outcome is assessed. Because as you probably know, the most important part of testing, especially automated testing, is the so-called assertions, where you check whether the result is what you expected. Now, I could go on for hours about testing, but I won't, because we only have, well, less than 10 minutes, and I'll briefly tell you a little bit more about these test design techniques, and then we'll have plenty of time to go to question and answers. So in TMAP, which is our body of knowledge for quality engineering, we have two kinds of test approaches. And the first one is experience-based testing. And in experience-based testing, we distinguish four groups of approaches, which are checklists that we highly recommend, which is error guessing, which we do not recommend, because there's a much better alternative to error guessing, which is called exploratory testing, because exploratory testing is a structured way of exploring a system. And you can imagine now that the definition of testing was verification, validation, and exploration. Exploratory testing is an example of this exploration. And there's crowd testing, which is using a lot of people that at the same time do some testing to give you quick feedback on specific things. But there's also coverage-based testing, which gives you a demonstrable coverage. So if people ask what kind of coverage level did you achieve, then you can't do experience-based testing, because with experience-based testing, you don't really know the coverage level. Still, experience-based testing may be very useful, but it doesn't tell you about coverage. To be able to tell about coverage, you need coverage-based test design, and that uses test design techniques. And in the world, there are somewhere between 25 and 30 test design techniques. And all of these can be grouped in one of these four groups. There are process-oriented test design techniques, condition-oriented, data-oriented, and appearance-oriented. And then these coverage-based testing are combined with experience-based testing, because together they bring you the verification and validation, mainly done by coverage-based testing, and the exploration, mainly done by experience-based testing, that together make proper testing. So that's why it says always combine on this slide. So in the TMAP body of knowledge on our website and in the book, we distinguish these 16 test design techniques, where you can see 3 from process-oriented, 4 from condition-oriented, 5 from data-oriented, and a number from appearance-oriented, where you see syntactic testing, which is functional, and where you see some others which are more the non-functional test design techniques. So all in all, this helps you to get uh, coverage-based testing. For example, if you do code coverage, you might do statement testing, where you look for statement coverage, or control flow testing, where, for example, you look for decision testing. So that's what I wanted to tell. And that brings us to the questions and answers. So, Karen, do we have any questions?
Yeah, I don't see any question yet. If you have any question for Rick, please feel free to write it on the Q&A chat. I have a question, if I may.
Of course, you may.
During your career, have you came across an interesting bug in production, like a special story?
Well, several.
I imagine.
What is which is related to code coverage, actually. I once was in a team at a client, and it was a bank, and we had software, or we had a system to support our clients, but the software was developed by an external party. And it was PC software for personal computers. And often when we tested it, we got the so-called blue screen of death. So we only had a blue screen, nothing worked. And we wondered about how can developers, because it was a strict developer and tester split, the developers were in a separate company. And we thought, how can this happen? Because the developers should have tested, and they also will get a blue screen of that. But when we asked them, they said, no, it works on our machine. You know, the typical works on my machine thing.
Yeah.
So we were a little bit disappointed, but then we thought, how can we go about this? And then we asked them, and you must know it was Java programming. So they used JUnit for their unit testing. At least that's what they claimed. So we said, okay, we have an add-on for JUnit, and that simply counts your code coverage. Now, and then we asked them, deliver the result from your unit testing by showing us the code coverage level. And we also told them, we think for the moment 75% coverage is enough. Now, probably if you have any experience with this kind of coverage, you know that 75% code coverage is not very good. But still, after that, we never had any blue screen, because you need to do some testing to get 75% code coverage. And if you have blue screen of that, well, yet you simply can't run anything. So that proved to us that the developers thought, we also have some testers, so we don't need to test ourselves. And that's exactly the kind of question that makes me so very happy that we have DevOps today, because in DevOps, the team takes responsibility together, and it's not us versus them, but it's we all together make sure that we have the right level of quality. But also, people should be aware that you don't strive for too much quality, because that's why sometimes developer, and you must know, I've been a developer for 20 years, don't like testers so much, because some testers are very nitpicking, and they are always finding where you think, whoever cares? I once heard somebody who found a problem in Microsoft Word that only happens if you have more than 32,000 pages in your document.
Wow.
Well, I don't know about your memos and documents, but I never create documents of 32,000 pages. So that problem will never happen. So that's the kind of thing that you need to take responsibility together.
I see. So, Rick, I see our time is up. I want to thank you very much for a great session. And for all of you, keep calm and keep testing.
And then we have a slight little problem, Karen, because we don't have any winners of the book. what I would say is people can, of course, have a look at tmap.net. And let's say the 3 winners of the book are the first 3 people sending me an email on this email address, and I will give them a download of the book. And well, if anyone else is interested, well, they can have a look at our website, tmap.net.
Okay, so thank you very much. I see we have a question, but our time is up. So if you can answer it later on the chat, it will be great.
I will.
So enjoy, everyone, and hope you were inspired by the session as I was. Bye for now.
Bye-bye. Thanks a lot. And Karen, thanks for hosting the session.
It's my pleasure.
Okay, bye-bye.
Bye-bye.